4. C, looking for vertical asymptotes and slant asymptotes. Which are easier? Vertical or slant asymptotes? Think the vertical ones are a little easier to find? Okay, let's see here. F of x is 9 minus x squared over 2 plus x. One thing that I don't like about this problem right away is that they sort of have the constant and the variables backwards. Do you notice that? I don't like that. I think they're doing it because of the x squared and the 9. But let's make it negative x squared plus 9 over x plus 2. It just looks a little bit more natural that way. All right? For vertical asymptotes, you simply think about, could anything cancel here? All right? Could I cancel anything? Well, if we go back to this problem and think about how the top would be 3 plus x and 3 minus x, could that cancel with the 2 plus x at all? Neither, right? Neither of those could cancel with 2 plus x. So nothing's going to cancel in this problem. And when we know that nothing cancels, there's not going to be a blank in the graph. Hole. The holes are created when something cancels. Nothing cancels, no hole in the graph. Good thing they weren't asking us for any of those. So, for vertical asymptotes, we're going to focus on the bottom, and we want to think about what makes this 0. So what zeroes out the denominator here? What value? Negative 2? Very good. So x equals negative 2 is where the vertical asymptote would be. And we're back, and you can see here that I graphed it. I'm graphing it on the calculator just so we can see. We want to make sure that we see negative 2 as the vertical asymptote. So we're going to hit graph, and here comes the function. At negative 2, it should sort of fear that value for x. So if you consider a vertical line here at negative 2, you could see the graph avoiding that red line, right? That's a vertical asymptote, all right? Let's move back to the worksheet here. Let's look for slant asymptotes. There's a 2-word phrase that'll help you find slant asymptotes. What procedure is it? Long division, okay? So we're going to take x plus 2, and we're going to divide it into negative x squared plus 9. This is the main reason why I wanted to make sure that we had it in the right order. I want the x to be in front and the x to be in front, the x squared, all right? Now there's one thing that I want you to consider here that I want you to do. This has an x in it. This doesn't have a plain old x in it. So what I want us to do is erase the plus 9, move it over, and add a 0x. We want to make sure that everybody's accounted for, from x squared to 0x to 9. Okay? It'll help a lot when we go to do the long division. Was your comment about that? Maybe? Okay. So what we want to do now is think about what would have to be up here times x to make negative x squared. The students say negative x. Yes. Good. Then what? Distribute. Good. Negative x squared. And what do you get on the second round? Minus 2x. Put a line under it. Subtract the whole quantity. So here's why we wanted the 0x there. Check it out. See the 2x and the 0x now lined up. If the 9 would have been there, you would have been subtracting 2x from plain old 9. Can't do that. They're not like terms. That's why we needed the 0x. Okay? These should cancel. And we should get 0x minus negative 2x. That's going to result in a positive 2x. Bring down the plus 9. Should we continue? The question is this degree smaller than this degree yet? If not, which it's not, we can continue. All right? So what goes up here that if you multiplied by x would give you 2x? Positive 2. Distribute it. Hurrying this along a little bit, we get 2x plus 4. We subtract the whole quantity, and what's our remainder? 5. The remainder 5 is a constant. That means it has a degree that's smaller than the variable x, or the expression x plus 2. Go. So the 5 is our remainder, and we add it onto the end. I'm going to change the color so you can see that the remainder is separate. Put it over the divisor. The part in red is the slant asymptote. Y equals negative x plus 2. That should be the equation of the line. Back on the graph, that if I enter that, negative x plus 2, go to y equals, and put in negative x plus 2, we should see this slant asymptote coming up in red that slices right through the graph without it ever touching. That is the slant asymptote.